How we doing, people? He's all right. Right, where are we? How are we doing, everybody? So, where am I this evening? I've got a couple of wee clips and stuff I've got lined up here. I'm going to talk about a couple of things. So, before I get into this, obviously, you know, there's a lot of talk about measurements and people trying to establish what the Earth is. Now, if you actually look into it, you know, the geometry that we're assuming that we've been using for forever, you know, the Earth has been measured. The Earth is measured every single day. The understanding that the Earth is a level plane is known and applied every single day. The only problem that people are encountering is that there's a confusion because, you know, we're seeing these images of a spherical Earth on the TV screen. We'll get into a wee bit more about the spherical Earth and its nonsense as we go on, but that's the be all and end all of this. We're going to look at Euclid's Elements and how it was even applied before Euclid put it into the book. Okay, I'm sure many people are aware of it. If people are not aware of it, I suggest that you start looking at these things. As I say, people are looking for proofsies, you know, and everybody's going on about visible phenomena. There's people wanting to do tests with lasers, you know, looking through cameras. Well, the practical everyday reality applied as a plane, we're using planar geometry. Okay, that's, you know, pretty much all you need. Again, you know, I understand how a liquid behaves, but, you know, that for me should be enough for anybody. But if we have to keep digging and we have to go further with it, then these things are where people should be looking, not waiting for some guru or some, you know, supposed authority on any matter to perform whatever experiment to prove it to you once and for all. It's already proven. Your confusion is happening because you see something on a TV screen. We will hear a couple of absurdities here in one of these wee clips, where for me it captures the crux of this whole thing, where people are teaching the fundamentals of our everyday reality or practical reality, and then at the same time making ridiculous statements that the Earth is a sphere. You know, and what we're going to show here is that it's impossible. Based on these applied principles, it is absolutely impossible for you to be living on that sphere. 2 seconds. You got that? So, where am I? Let me just line up what I'm reading here. What was I saying? Hello, everybody. Mr. Cheswick, good wee video a minute ago. You know, I watched Mr. Cheswick's just latest upload there. Craig talking about, you know, people's stupidity and how he's going to call them stupid until they go away. Son, anybody out there that thinks that the Earth's a globe, you're the stupid one. You've been shown numerous times that it's demonstrably a level plane, yet still try and defend pseudoscience absurdities because of a cartoon image you see in your TV, so deeply rooted in you, your emotional attachment to it is palpable. You have to be an absolute moron now at this point. Anybody who has researched enough into this topic, you know, to still try and postulate it's a cartoon globe, you've got something wrong with you. There's something missing. And then to make statements like the military could never be involved in perpetuating lies and propaganda. Wow. Wow. You know, one of the biggest cults going, right? We are, you know, follow thy leader attitude and no question. It doesn't get any more culty than the military, I'm afraid. Craig, pull your head out your arse, son. How are you going to deny this? How can you continually keep denying facts? How can anybody keep denying the facts? It's preposterous. So we assume it's a plane. We use geometry that assumes it's a level plane, and it's worked for thousands of years and continues to work right to this very day. These very same people have to deny their own existence, their own practical everyday existence to maintain a religious belief. I was laughing again earlier with Gav about this geometry of the globe and removing the oceans and how it's this weird shaped potato, and you know that doesn't have a geometry. You know, how can you have an outside that's a perfect circle with this crazy potato shaped rock in the middle? You know, and then postulating that mass creates a bigger gravitational field and all that stuff. Well, how can you have that? Where's your centre of this potato rock? You know, there's more mass over here than there is over here, so there's less gravity at this side. It's total nonsense, man. The more and more you start to delve into this stuff, it's just an absolute joke. A total and utter lunacy. It doesn't have any merit at all. The only thing that's managed to give it merit again is these images on the TV screen. Do you believe an image on your TV screen over an objective fact? Do you ignore objective facts based on an image on a screen? That's what these people are up to. So for me, after this, you know, anybody who did have any doubts, you should have none. Absolutely none. There is no escaping this. Anyway, I'm going to wait for Gav before I get kicked in with this stuff, so I'll just say hello to everybody while we are waiting. The Realist, James Gatoliot, how he's doing? Shotgun Sus, Stuart Lundy, how you doing, mate? Tony T, Mr. Teddy Bear, Sules, H4XOR. Anyone that says flat earthers are stupid has clearly not looked into or tried to prove it to themselves whatsoever. Just depends what we mean by a flat earther. Robert Matthews, how you doing, mate? Paul Etchells, Level World, how you doing? Stephen Parker, Mr. Cheswick, James Gatoli, Highway Child, 450X Mobber, Hazmat, David Thompson, John McDermott, Witty Woo, Hazmat, Russ McGarry, Paul Etchells, Sherlock Holmes. Oh, for fuck's sake, what's happening here? So I jumped. What the fuck's going on? Master Bevs, I'll just start from there. Individual Perspective, Tony T, One Man, he's Detector, Execrate 200, how you doing? When Benjamin is pleading for someone to tell him what the earth is, he needs to get on here and be told exactly what it isn't. Yeah, that's it. I don't even know where I get. I've seen everybody in a frenzy about some celebrity. I don't know celebrities. I'm not really into mainstream or any of that stuff. So I don't treat anybody as celebrities and prop them up there and get on a tizzy, you know. But aye, anybody that's questioning, they're more than welcome to come here. Everybody knows that. You know? Scott Gallagher. And we've been brainwashed to believe the so-called experts. That's it. The Mad Flatter, West Coast Wisdom, how you doing? Colshy Cats, how you doing, mate? TP in a Tree, how you doing? Phil Jones, Stephen Crumley, Sidel Carchi, how you doing? I'll get to Alan as well. If you hear this, I'm going to get to some of the things people have sent me. I've just not had time recently. Anthony Bingham, DJ Danny, Burnett 444, Spherical Cow. No, I don't think I'll be opening the platform this evening. I'll see how it goes. I'm not on the OBS right now, right enough. So, Phil McCavity, how you doing? Pat Mustard, Achilles Arrow, Hazmat, Stephen Watson, David Thompson. Yeah, I'm warm enough. It's I've stuck a bit too much in the burner, methinks. I might be displaying some sweatage. Sorry, I'm wearing black. It will no show up. My makeup crew will be all right. They'll not be disappointed, you know. Not to worry about. Kennel, how you doing? Grissu, Globus, the one world religion. RV is saying you're a Freemason. Ugh, whatever, fuck that wee bitch. Not interested in wee bitchy gossips talking about people, whatever. Flair female, how you doing? It's a tonic for you this evening, is it? Bad day. G-Bird, Witty Woo, Beyond Belief, how you doing, mate? Harry Hepworth. Pandemonium, how you doing, mate? Yeah, it's the fires of hell, certainly is. Oh, you're no well. Oh, it's a wee shame. A wee shame. I do feel for you. It'll go away. Don't worry about it. Andy Baldwick, how you doing? Good times for all. Celtic 67 RV has totally exposed himself. No point in bringing up anyone exactly. It's just a fucking irrelevance. Again, I'm going to look at this stuff. You know, coming up, people who profess Christianity and empathetic type beings and stuff like that. We'll have a look at what some of these characters display. Because I tell you what, none of these people are walking that walk. You know, they're using buzzwords and mantras and swaying people with their linguistics. But, you know, their walk tells me everything. You know, as soon as we start seeing people using propaganda techniques and trying to tarnish somebody else's character and make outlandish claims about their character, it's a total irrelevance. Said that from day one, probably the very first video, the second video, you know, that I ever put up on YouTube. If we're looking at, you know, who people are, that, you know, you've went off the mark. It doesn't matter who people are. What you should be doing is discerning for yourself. You know, looking through information and figuring out what's real and what's not real for yourself. If you're swayed by a persona, you're a moron. You're part of the problem. You are the very same people who allow this structure, this cunty bollock structure and its methods to be perpetuated because you're so fucking gullible and stupid that you're swayed by hearsay and bitchy whispers. So we'll be having a look at the walks. And again, all this talk about race and generalising, it's them, it's that group of people, it's that. No, I identify a mindset. The mindset of an individual will be revealed to me through their walk. If you're going to say there's any sort of enemy, how are you going to identify that enemy? Oh, look, it's wearing that robe, therefore that's my enemy. No, no, no. You have to understand the mind games, the mind warfare. That's what you're involved in. War of information and how you decipher information. So we'll be looking at that in the coming future. How to identify these fuckers. Because I tell you before, they'll hide behind any old fucking robe. Gav, how you doing, mate?
Good, Dale. Yourself?
Good. Good.
People.
How are you?
Aye, sound.
All right.
Actually playing a wee bit of music with my daughter today. So
excellent.
I'm glad she's getting into that age where her father's not an embarrassment to her anymore, but she's...
That's, aye, well, it's an asset.
She's an asset.
Yeah, you bump up the credibility now. Wheel my dad out at the party and he'll play a bit of guitar. Look at him, he's cool as fuck, you know.
Right, no, otherwise all good. Just another rainy Wednesday here.
It's been all right here today. It's getting colder, so I think we're in for some freezing temperatures apparently.
About time, a bit of snow would be nice, wouldn't it? If it didn't just go away in 3 hours, you know.
Exactly.
You know.
Exactly. Aye. Bit of sledging with the winds and then get to fuck, you know.
Then the summer can come again.
Aye. Aye. Bike weather, get the bike weather back here rapid. So obviously, you know, this is going to be a bit this evening, Gav. So I'm just trying to think where would be a good place to start.
I was just going to point out one thing, Dale. So in the title of this video, you've misspelt the word measure.
All right. Have I?
And yeah, it's not a big deal to correct it.
I've missed out the S. My bad.
But maybe just starting with some definition of terms would be quite good, you know. So I think everybody knows who Euclid is, or at least they'll have heard of him. The philosopher and mathematician who apparently, you know, I mean, it's what, 1500 years ago now, wrote the Elements. And obviously in those days, they would have had a bunch of scribes or scholars who were, you know, doing the work for him, and he oversaw this book, if you like. And Euclid's Elements was basically one of the first books that tried very decisively and how should I say, very precisely to start defining based on definitions and axioms. So the whole idea was that you can maybe postulate four axioms that you believe to be true to begin with, and these should be self-evident things, right? They shouldn't be made up fantasy, but you would basically, you know, start with those four axioms, and the idea was then to develop the whole of geometry based on those four things. So a very, you know, structured way of presenting geometric propositions and using obviously real geometric tools, so compass and ruler and the things to make that. So the Elements is basically one of these books that has been around for 1500 years, and Euclid is the author or editor of it, at least.
Yeah, sorry, Gav. Xander, I'm on live. I'm on the live just now. Right, we'll do it after. I'll do it once I'm finished. Aye, sorry about that. I just want to add in here, you know, in regards to time scales and dates and the amount of years and stuff like that, you know, I'm not professing that any of that's, you know, factual, accurate in any way, shape or form. I'm just going to take, you know, what they offer us at face value and take it from there. Yeah. So
I would agree with that, Dale. So I think it's not clear to us, you know, exactly how far back it goes, but that's the standard narrative anyway.
Yeah.
And the book has certainly been around for a long time, obviously in various languages like Greek and Arabic and Latin. And I think the first sort of English books were around the 1700s, 1600s, somewhere around there. And it's been used basically ever since. I mean, it is the mathematical Bible. Every mathematician will say that if anything in Euclidean geometry fails, then it all fails, right? You know, I mean, it's one of the absolute pillars and foundations of mathematics and geometry, right? So, and we know that, and we'll go in more detail in a minute. And the other term I just wanted to highlight was the word measure. That measure is basically a mathematical tool to decide what is your unit-based measurement, right? If you want to then find out how many times does this unit fit into another, into something else. So if you think of a length, you know, and I want to know how long something is, then I have to define a measure of it, right? So I could take Dell's foot, I could take Gavin's foot, you know, our noses, the length of our penis, you know, you can take anything, right, as a base. And then you find out how many times does that fit into the length, so how many multiples of it can go in there, right?
Is that where the inch? Is that how they get the inch?
Well, you know, the Scots, we measure in leg lengths, don't we?
I think they were bumming themselves up.
Probably, but so I just, you know, measure is one of these, you know, it is also the root of all mathematical manipulations of ratios and numbers, right? So a measure is it's very decisively tied into how mathematics is defined. Mathematics is the doctrine of ratio and measure, right? That's really what it's all about. And you can look at it as a measure, of course, as a geometric length, but you can also look on it just as a number and say, you know, I'm going to play with numbers and equations and things like that. So I just wanted to try and at least define what we mean by these terms before we started. Anyway, it was a good starting point. Off you go.
So, you know, I read you that thing about Lincoln. I'm going to leave that to a wee bit later, actually. We'll just get to one of these wee clips. Hang on. What was that one? Let's see. We'll start with this. It's a 12-minute thing. We can skip through certain parts of it. But you obviously just pipe in, Gav, you know, because this one, I want to highlight this first and foremost. Obviously, with the absurdity, I'll let you hear a bit of that earlier. So you kind of know what's going to be coming, but
all right, go for it.
Just to show, you know, these things are being taught, and then there was like the switcheroo, you know, that people are blinded by, you know. Hang on. Right, seeing this okay?
Yeah, if you could just make it cinema mode or something, then it would be bigger on the screen.
Is that better?
Aye, that would be better for the viewers, I think.
And welcome to today's lesson. What is Euclidean geometry? Have you ever wondered what the word geometry means? In this lesson, we join Eloise in a quick history lesson to discover what Euclidean geometry is all about. We also see how we use it in the real world. Joining us today,
Which is the important part.
we have Sharon. Hi, Sharon. Where are you and what are you doing?
Hi everyone, I'm here in my dad's study trying to find out where maths comes from and who invented it.
And what have you found?
Not much yet, although I think I might need some help.
Maybe I can help you. I have found a few things. Take a look at this. The world over, every civilization.
There's your first absurdity.
Yeah, where the fuck did that come from?
Exactly.
That's not the way Euclid's Elements started.
Yeah.
Throughout history has measured the heavens, the earth, and achieved great feats of construction.
They never measured the heavens because they never tangibly went there. They just made assumptions.
Yep, invisible proofsies.
Yeah.
Mathematics used in those ancient.
But for this, you know, we're talking about Earth measurement here, what's applied here on Earth. You know, the visible world, and making assumptions and postulates and coming up with all sorts of nonsense.
Times continues to be used today. Geometry. The earliest known use of geometry was for measuring land. So the word geometry comes from geo, meaning earth, and metri from the Greek word meaning measurement. In 3000 BC, the lands of Egypt and a part of Iraq, known then as Babylonia and Assyria, were flat, and the large rivers flowing through these countries often flooded.
What was that? They were flat?
Yeah, you better repeat that bit.
Aye.
And that after every flood, the people living on the river banks had to measure out the boundaries of their land. This made them experts in the geometry of flat surfaces very quickly.
Hear that?
Yeah, I mean that's the narrative that, you know, I've been taught as well, that, you know, the Nile flooded the lands, you know, every year, and all the markings and divisions of the land and who owned what, and the boundaries and properties were all lost. So they basically had to remeasure the stuff again.
Again, you know, we're not taking these things and proposing them as factually accurate or any of that kind of stuff. We're just going to take it at face value and what they're offering. You know?
Learned how to create right angles, use right angled triangles, and they could calculate areas using simple multiplication. The ancient Egyptians went on to use their knowledge of geometry to put up huge buildings that still stand today. In those days, concrete had not been discovered. So they had to use their knowledge of geometry and their skills in stonework in order to build these huge buildings. They did this by using huge hand-cut blocks of rock and fitting them together like a puzzle. But it was their knowledge of triangles that led the Egyptians to develop a calculation for their most famous monument, the pyramid. Their measurements were so accurate that these monuments have lasted for over 4,000 years, and today we accept the pyramids as being masterpieces of straight-line geometry.
Wow, buildings that have lasted over 4,000 years and they didn't even use cement? That's pretty amazing.
But have you thought about what was happening in the rest of the world at the same time? Say, somewhere like China.
Well, let's have a look.
During that same period, the Chinese also suffered from floods as the Yellow and Yangtze rivers often burst their banks. And their answer was either to build dams to hold the water or dig canals to let the water flow away.
You know, again, you know, they understood the principles, they understood how liquid behaves in order to even build a dam or a canal in the first place.
Oh, absolutely. I mean, we're talking about the very definition of plumb and perpendicular, right? Which would be based off of the level surface of water and a spirit level.
Exactly.
By 1000 AD, the Chinese had developed new skills. They could build ships big enough to sail around the world, although they never sailed them that far.
Note the programming aspect of the imagery being inserted in continually, and then we'll hear.
And not really with any relevance to the actual topic of what they're saying. It's kind of thrown in there as, you know, we went round the they win a ball.
As part of the NLP, it's just reaffirming the program, you know, keep making sure that it's maintained within the consciousness of the viewer.
Yeah.
It's subtle. And you'll hear and see the blatant contradictions coming up shortly.
So, what maths do you reckon they use to build all these things? Geometry? You got it. Let's carry on and see what else was going on in the world then. If the Chinese had sailed across the Pacific Ocean to Central and South America, they would have come across the people of the Aztec and Mayan civilizations. Like the ancient Egyptians, they used geometry to build their own magnificent pyramids.
So if you take any of this to be true, you know, these accounts, these historical accounts, how is it these people were coming up with the same things at the same time when no way of contacting each other, apparently?
Good point. You know, unless it's based on natural substance and the physiology that we all share, you know, then why would people come across the same thing? Yeah.
Exactly. You know, the self-evident truths of our reality would lead you there if you were on a quest to figure it out.
Absolutely. Well, there's nowhere else to end up.
No.
Temples. But from about 600 BC, Greek mathematicians went a step further. They started to write books to explain and prove mathematical theories. And many of these mathematical theories and proofs are still studied in schools around the world today. Galileo Galilei, an Italian astronomer and physicist who lived in the 17th century, saw maths as a tool and a language to describe the world. He wrote,
"The great book of nature lies ever open before our eyes, and the true philosophy is written in it. But we cannot read it unless we have first learned the language and the characters in which it is written. It is written in the mathematical language, and the characters are triangles, circles, and other geometric figures.
Characters which are based in reality, founded in the objective world, no in abstract fantasy realms."
Well, obviously, at some point, somebody decided to formalize it into a language that then, you know, only mathematicians are supposed to understand.
Yeah.
You know, I think, you know, the geometry to, or the use of geometry and then the change into things like algebra and disciplines, I think is where the formal part comes in, yeah?
Exactly, because the practical would have came first without any language ascribed to it. The practicality came first. Yeah.
think about it. People have been using geometry from as far back as 5,000 years ago.
Now, if you take that at face value, pay attention. You know, once you understand this, saying 5,000 years, okay?
Now that's amazing. And it's the same kind of geometry we learn in high school today. As long as humans have lived in communities, people have used maths to measure the land, construct religious buildings and altars, and calculate the positions of
Use the language, calculate.
stars and planets. In fact, we still take our calendar and our measurements of time from the positions of the stars and planets. Today in schools, we study 3 types of geometry: Euclidean, coordinate, and transformation geometry. So
You want to say anything here, Gav?
I'm not quite sure that these categories are quite correct, in modern parlance.
Transformation, man.
Yeah, I mean, transformation would be, generally speaking, linear transformations they're talking about, which is the movement of a line in Euclidean or Cartesian coordinates and moving it to another place by applying what they call a transformation. So nowadays it's more called affine geometry, I would say, which is basically the study of parallel lines. And it's the base and cornerstone of geometry, affine geometry.
Cool.
Let's start with Euclidean geometry.
Whoa. Heavy feedback there.
Sorry, was that for me?
Maybe, I don't know if your earphones or something had slipped. That's the way it's gone now.
After the Greek mathematician Euclid. He became famous by putting together a set of 13 books called Elements. In this collection, Euclid recorded all the mathematical statements and proofs that the Greek mathematicians of his time had constructed. Then he arranged them into a formal system. His focus was on using logical thinking and deductive reasoning to make mathematical statements and then go on to prove them.
So Dale, maybe just to stop there, we've highlighted this a few times, the difference between deduction and induction. The very fact that, if you take a bunch of axioms like the ones that Euclid defines, and from them you deduce everything else, it's a much different way of approaching things as compared to the modern way of doing it, where you hypothesize a more general theorem and then you try to prove it wrong, and as long as you can't prove it wrong, it's held to be true. So deduction from axioms or from known facts is what the world is built on, and not from inductive ideas and general hypothesis that we're supposed to disprove.
So at the end of the universe, there is a unicorn that's shiting all this experience out. So until I'm proven wrong, it stands as a truth,
Yep, absolutely. Until somebody proves you wrong, Dale, there's nothing we can do.
All hail the unicorn.
Statements that had been proved to be true, theorems. But this isn't just history. Today, much of our school geometry comes from Euclid's books, the Elements, sometimes referred to as plane geometry. Euclidean geometry focuses on points, lines, and shapes on flat surfaces or planes. It is not concerned with what happens when the surface curves.
Just stop there for a second, Dale.
Yeah, well, I was just going to let her get her wee fucking zinger in there.
All right, okay. On you go then.
Hold on, let me just go back a wee touch here.
Today we know the world is not flat, but still people like builders
and a little spinning globe as proof, huh?
Right, so, we're talking about plane geometry. It's no concerned with a curved surface. And then straight away, we know the world's not flat. It's a ball. Look, there's my plastic toy spinning. But now she's going to go on to say this wee bit. Sorry, Gav, just let this play out here and then we'll stop it. Huh?
Absolutely. Go for it, man.
Today we know the world is not flat. But still, people like builders, carpenters, and surveyors, engineers, navigators, and scientists use facts recorded in Euclid's Elements to solve problems involving triangles, circles, quadrilaterals, and other geometrical shapes.
Right. Yeah.
Yeah, absolutely. So, I think that makes the point very clear that, despite all the imagery and the talk about, spaceballs and other nonsense, here down on Earth, everybody uses Euclidean geometry to do everything, right?
Yeah.
So,
this is this nonsense again, the subtlety of the programming, that switcheroo again, Gav. These people even here, they probably don't fully understand what it is they're reading. They're probably just there to perform a job. But anybody who's really understands what it was they were saying, to then follow that up by, it's not concerned with a curved surface oh, we know the Earth's no flat, it's a globe. That's just absolutely ridiculous. You can't take these principles that are applied and work in the real world and apply it to a curved surface. It just doesn't work.
And let me try and give a little bit more explanation as to why that doesn't work, Dale. So I don't know, can you make my screen bigger, my face? And
just need to stop sharing. Give me 2 seconds. I'll come in. Go for it.
So I've just drawn on a piece of cardboard here, right? Which is a planar surface. Yeah,
yep.
People can see. You know, 3 different shapes: a circle, a square, and a triangle. Yep. Now, you know, everybody knows that the sum of triangles adds up to 180 degrees on a plane, and it doesn't matter how I orientate this plane. You know, it can be flat walls, it can be in any direction or orientation. Nothing is going to change about the properties of that triangle, right? Yep. But if you were to take a balloon, right, and not inflate it and draw a triangle on it, yeah, and then blow up the balloon, the bigger you blow up the balloon, the properties of that triangle are always going to change. Yeah. So the angles are going to change. The bigger it is, the bigger the angles are going to get. Yeah. So there's no such thing in spherical geometry as the concept of congruity. These things, you know, if I draw a little triangle and a big triangle, they're congruent to each other, right? You know, I can scale things. Yeah. But you can't do that on a sphere. And you know, the practical world shows us that we need to scale things, right? We need to be able to construct models, scale them, build them bigger, and we've been doing it. I mean, the size of these pyramids are fucking amazing, right? So, you know, we can make little pyramids and big pyramids, right? But you couldn't do that using spherical geometry. It's not possible because, as I say, the angles don't add up. You know, they change with the size of the sphere. Yeah. So the very thought that, you know, the radius of the Earth has to be this 3.438 ratio of nautical miles, as we've discussed before, to make the angles work, right? If the Earth was smaller, it wouldn't. If you look at that guy Soundley's pictures, where the curve of the Earth is supposed to be happening in 4 miles, and the size of the Earth is that size, it would have a completely different angular geometry than the one that we're told, right? So you know immediately that these things are nonsense, right? Did I make my point okay?
Of course. Yeah.
Okay. Want to make sure it's sometimes difficult to get these concepts across simply, you know, but...
Yeah. So the main crux for the layman is to understand that, you know, this is the assumptions that people are having, you know, that we're on a plane, and we're applying practicality to those principles. That's the foundation of what you call, you know, your civilized life. That's what it's based upon. But again, going back to the beginning of this, people are in conflict and confusion because you have an institution who are professing to be at a vantage point, showing you something that's contrary. And as Gav just pointed out, none of that stuff would work or apply on a sphere. You know, we spoke about that in navigation, triangulation, trying to pinpoint each other. You know, if I'm using the tools of navigation, my horizontal is something totally different from Gav's horizontal. You know, things would be way off. You have to, you know, start from the axiom of a plane so that we're all on the equal level, and then we can work in regards to navigation. But,
yep. And I just wanted to throw this slide up. You know, I know we showed this fairly recently, but you know, what that lady was talking about is everything here on the bottom here, this geometry of physical space. Yeah. And the fact that it all is used in construction and manufacturing, transport, engineering, mathematics, right? Yep. And it is very much a part of our lived life. Yep. Whereas the geometry of visible space is all about seeing is believing, right? And, you know, we can come a little bit more and explain this as we go along tonight, but I just wanted to point out that what the lady's saying about Euclidean planar geometry is everything to do here with the bottom half of this slide. Yeah. Yeah.
You know? The wee diagram showing you Cartesian. You know, that's what we use in regards to navigation. You know, so you know, we move in 3-dimensional space. So your x is your longitudinal, your latitudinal, and your vertical.
Well, absolutely. I mean, there's a concept in navigation and sailing, and it's called plane sailing, which basically just assumes that you're on a level plane. Yep. And for all practical purposes, that works just fine. Yeah. Yep. So, you know, I mean, people can look up plane sailing. It's, you know, it's fairly clearly said that, you know, plane sailing is good for small distances anyway. And for large distances, you're supposed to take astronomical observations and look up sight reduction tables, right?
Yeah.
That are supposed to, how should I say, correct for the false assumption. But my feeling is that the false assumption is that we're seeing planar and we're not seeing visibly spherical. Yeah. But anyway, that would maybe go too far. What I really just wanted to point out was that lady is talking about the geometry of physical space. We know it to be true. We know it to be always part of all the constructions and everything we do. And for however long we want to believe the history is, you know, we're talking at least 500 years is my, you know, I can go along with that. And 500 years of lived life that shows Euclidean planar concepts work is you know, proof enough for me, the self-evident truth of it. You know?
Exactly. You know, and two engineers with a expanse of water between them, even 3, 4, 5 miles. That's the principles that they're using. They're using the Euclidean plane principles. That's where they're working from, and they work towards each other to construct the bridge and the crossing. They understand the water beneath it is level, parallel. It's a parallel plane. You know, I mean, this is the practical world. There is absolutely no way that anybody can escape any of this stuff. Only if you're willfully ignorant.
Yeah, only if you want to believe imagery, TV, you know, narratives, stories, or if you're more academically minded, you need to get lost in the mathematics. Yeah. And think that is true, that is reality. But as we've seen, mathematics is just definitions. I mean, it's what Euclid did too, right? Euclid said, okay, I'm going to start with 4 definitions. But what Euclid's doing is taking it from a basis of looking at lived life and saying, okay, I can take these as self-evident truths. But when you start to, you know, come up with a mathematical definition that's not based on reality, that's not verifiable by anybody, that you cannot judge for yourself, that you have to believe some guy in a white coat or some scientist or some academic or some authority, then you've given away the right to judge for yourself. And that's what we've done, right? And we willfully let them tell us stories instead of looking objectively at our reality and saying, do these axioms, do these definitions jive with what we see and what we experience? Yeah. And, you know, they obviously don't. You know, I don't see any curves when I look along the horizon or any water, right? So, you know, it's patently bullshit.
And again, if it was trying to apply Euclid's postulate to your construction or your navigation, it would be way off. None of it would fucking work. As I pointed out, you know, with the postulation of building a square plumb level construction, if you build that in the top of a curve and you continue that, the gap's going to increase at the bottom. You know, you're going to be way off. It just wouldn't work. You know, any layman that builds a fucking fence, people who are doing this stuff every single day understand these principles. Yep. You know, it's not about these priests in high places babbling mathematical equations and fucking abstract nonsense at you. The real practical world is telling you what it is. And that this bullshit, it's only flat locally. Well, you know, as we were laughing earlier, Gav, you know, everywhere would have to have a locally flat. You know, so what does it actually look like then? I mean, it's fucking preposterous. Yeah,
if everywhere's locally flat, then where's the fucking curve as well once we stitch them together? It's preposterous, yeah.
And how are you going to account for it? You know, where is the fucker? It's always just imagining. It's just beyond that point there somewhere. There's no fucking there either.
Yeah.
Yeah? And a sphere does not have a flat point on it anywhere.
Yep. And I just want to make one point, you know, without, you know, saying anything too deep, but, you know, I've been there, Dale, right? So I sat in those academic chambers, right? I got mind conditioned to believe mathematics is a wonderful thing, yeah? And I do believe it is a wonderful thing as long as it's rooted in reality. You know, I'll never go against that, and useful in all kinds of engineering things. But I've sat at these lectures and listened to cosmologies and, you know, got my wee pencil out and did my exams and got my wee degree and, you know, ran away thinking I was the king of Siam, you know, and I was a real smart chookie. And it's only now when you look back at that and you think to yourself, well, all that was just stories, narratives, and mathematics, right? Man-made, formal, defined languages. It had nothing to do with me going out and experiencing reality. I was literally in a lecture hall listening to some guy and with my mouth agape believing him, right? You know, I mean, I can see it clearly now, you know?
That's it, you know, come here, Gav, we're going to build this wall. Can you bring your astrophysics expertise out here, my man? You know, let's construct a level and plumb wall, shall we, using your astrophysics postulations?
I'll be absolutely honest, Dale. You know, I wouldn't known how to build a brick wall back then. You know, and I probably sat there picking out Schrodinger's equation and trying to apply quantum mechanics to it. You know, and that'd have been a total failure.
I don't know if it's level, but I don't know if the cat's deep. The cat might. And that's the honesty, Gab, because that's the majority of these clowns that we see online here. These gamer boy fanboys, NASA fanboys, spouting all this fucking garbage. Ask one of them to go and apply their bullshit to a practical, real world application. It's just not going to work. And these wee guys don't have a fucking clue, you know?
Yeah, I mean, I don't know what their histories are, but, you know, I doubt any of them have had the education that I got, you know, so in that respect, they're even more, how should I say, gullible than I was still.
Right. I mean, even in the military, I was talking about military earlier, you know, these postulates, Euclid's postulates, they're even applied in regards to things like a submarine. You know, the trajectory of missiles, how to pinpoint a target, how to know where the target's going to be in relation to your speed, the angles accounted for. It's all being applied everywhere. You know, there's nowhere in reality that it's not being applied.
Yeah,
you know?
I mean, I've seen so many examples on the internet of, you know, somebody saying, oh, look at this manual from the military. And if you look just at the introductory paragraphs, it usually starts with something. The rest of this book will assume that we are living on a flat plane, you know? Right. So, I mean, I've seen so many of them, whether it's maritime navigation or aircraft flying or, do you know what I mean? So surveying, you know, so yeah.
That's when they come in with their rhetoric, their wee trick of, it's just locally. Oh, it's just locally. It's so big, you know, fuck off. You know, you're not getting away with that. It's impossible to apply these principles to a fucking any sort of curve. It just wouldn't work. And any layman out there knows that. You ask any bricklayer, any constructor, anybody, they know that it just wouldn't work. You know, all the diagrams start with a vertical and the horizontal, and that's how they work everything.
Yep. And that, by the way, that concept of, you know, perpendicularity, which, you know, mathematically they call orthogonal, right? Is also the same concept that's used on a sphere. So at the equator, for example, you know, you have an orthogonal line as one of the meridians. Yeah. So it's, you know, they're keeping parts of the concept in place for their model to work. You know, it's only when they then start to, the poles, everything gets thinner together, and, you know, so they draw on these things when they need them, and when they don't need them, they'll cast it aside and go into metaphysical lunacy land. Yeah.
Exactly. I don't know if we want to continue with that one. I can't remember what else they offer, but I've got a couple other ones. Let me just see what I've got here, and you can decide what one we want to have a look at, Gav. Hold on. So I've got one there, it's Bodaguru, Mass Geometry in Ancient Times, Introduction to Euclid's Geometry. What was the other one? That's the Khan Academy one. Euclid is the father of geometry, Introduction to Euclidean Geometry.
I don't think I've seen that.
You want the Khan? Well, we'll stick the Khan one on.
Stick Khan on.
All right, hang on.
Khan's a very big online teaching resource or academy. So.
Yeah, sorry, hold on. So what's this? Meryl sent me something. Hang on, I just got a wee look at this to see what this is. This is another video. Solar Astronomy Probe, Ulysses, Solar Odyssey, circa 1989, NASA Jet Propulsion Laboratory. I take it this is going to show us some geometric plans or something. Meryl, I don't want to play through it and disrupt the ones I already have up. I can see that they're showing some sort of planetary movement on a plane. Again, using a Cartesian box grid. And, you know, I'll just share that screen quick so you can see what I'm looking at. But I'm not going to play that video right now. Hang on. Probably, I'd assume this is what Meryl was pointing
orbit the sun.
So even as a child, I remember them. They used to show us this kind of planar movement. Sorry, stop screen sharing a minute. Yeah, that's what Meryl was pointing at. So let me see. So it was the Khan Academy one.
I'll be back in a minute.
Aye, okay. Well, I'm no bother playing that just now. What I want to read out is this. This was a interesting thing. Euclid was the founding father We hold this mathematics to be self-evident, by Adam Kucharski, October the 13th, 2016. Despite the man's awkward gestures, unkempt hair and ill-fitting suit, it was one of the most extraordinary speeches that the Reverend John Gulliver had ever heard. It was March 1860 and the venue was Norwich, Connecticut. The following morning, Gulliver struck up a conversation with the speaker, a politician by the name of Abraham Lincoln, as he caught a train down to Bridgeport. As the pair took their seats in the carriage, Gulliver asked Lincoln about his remarkable oratory skill. I want very much to know how you got this unusual power of putting things. According to Gulliver, Lincoln said it wasn't a matter of formal education. I never went to school more than 6 months of my life, but he did find training elsewhere. In the course of my law reading, I constantly came upon the word demonstrate. Lincoln said, I thought at first that I understood its meaning, but soon became satisfied that I did not. Resolving to understand it better, he went to his father's house and stayed there till I could give any propositions in the 6 books of Euclid at sight. He was referring to the first 6 books of Euclid's Elements, an ancient Greek mathematical text. On the face of it, Euclid's Elements was nothing but a dry textbook. There were no illustrative examples, no mention of people, and no motivation for the analysis it presented. But it was also a landmark, a way of constructing universal truths, a wonder that would outlast even the great lighthouse in Euclid's home city of Alexandria. Elements proposed that definitions were at the foundation of knowledge and led to self-evident axioms that needed no proof. From these definitions and axioms, Euclid showed how to prove dozens of mathematical propositions, producing knowledge that was objective and undeniable. A person of reason would have to accept a proven fact, no matter what their personal beliefs or convictions were. So, before I read any further, we've got talks there, about first principles. Elements proposed that definitions were at the foundation of knowledge and led to self-evident axioms. The self-evident axioms come from, as we've spoken about many times, lived life. What do we share in our objective reality? What can we discuss with each other and practically demonstrate to each other to have a further knowledge, a knowing of our objective reality? That's where it must remain. You're talking about demonstration, and he thought he understood it. Well, in the terms of this, when we come to the objective world, demonstration means practicality. It means defining things based on something in the natural world that we all are witness to. And I don't mean looking up the way. That's not part of your three-dimensional existence. We can't all move three-dimensionally around these supposed solid objects above us. We're talking about here on Earth in the real world. So, dozens of mathematical propositions producing knowledge that was objective and undeniable. A person of reason would have to accept a proven fact. So just as we're showing right now, these are facts. These are demonstrable facts applied in everyday living. So what kind of person are you who denies them? What's your motivation for denying them? What's your reasoning? An image on the screen? A wage? Stature? Dishonesty is what you have to exert and show, if you want to maintain the belief in the heliocentric Big Bang globe Earth cosmology. Because none of that's a self-evident fact or truth of any of our existence. Absolutely none. We see a parallel flat line. We measure such. We apply the postulates of Euclid in everyday living. But it's on a sphere. Don't fucking well think so. Elements would become a best-selling work, second only to the Bible in printed editions, and used until recently as the standard text for mathematics classes, until recently, maybe a couple of 100 years ago. A profound...
So we didn't go through Euclid's Elements anymore. I never got it at the school. I never got it at the university.
No. Exactly, mate. As we spoke about before, this late 1700s kind of era seems to be the time where a lot of this stuff was pulled back and removed and kept, amongst the select,
Yep, it certainly wasn't used as a foundational text, you know.
No.
I've actually got the first 2 pages of the 2 important pages of Euclid's Elements in front of me here, Dale. I don't know whether, you know, it makes sense to just look at them, just to show how simple the things are from which he deduced the whole of construction, right, and the whole of engineering. Yeah.
Perfect. I need to make a smoke, so I'll present you, and you go for it, mate. I'll go back to that thing I was reading because there's a couple of interesting bits in there.
Yeah, so Euclid's Elements basically has what he called universal ideas and what he called necessary concessions. Yep. So universal ideas are, if you like, truths that, as far as we know, what Euclid proposed is these things here. So equals to the same are also equal to each other. It seems like a fairly self-evident statement, and as soon as you can read and you understand what these words mean, you will agree that if something is the same as something else, then the 2 first things must also be equal to each other, right? And also things like if you have equals and you add equal things to equals, then at the end it's going to be equal.
Yeah.
And the same if you subtract them. And that things coinciding with each other are equal to each other, and a fairly obvious one that the whole is greater than the part. Right? Well, so they're fairly simple ideas that everybody can immediately agree to.
There's a bit in this thing that I was reading, Gav, that disagrees with that. I gave an example, but I can't remember if it was something to do with practicality or you know, some sort of philosophical point that was being made. Hang on a wee second, just take it back and read. It's just that number 5, and the whole is greater than the part.
Okay.
Hang on a wee second, just to find it on this. Sorry, just bear with me. I find this.
Right, no bother. I'm up for any kind of discussion.
Oh, I don't know what's going on here, but is it? Is that it? Sorry, just bear with me. I'm having to read through this.
No bother. You want to share the screen? Or?
I'm just trying to find it. No, I wanted to leave your screen. By the end of the century, mathematicians such as George Cantor were going further and finding paradoxes and inconsistencies at the very heart of pure mathematics. The predecessors had developed theorems based on the intuitively evident laws of nature, such as Euclid's axioms, that the whole is greater than the part. Real-life intuition suggests this statement is always true, but Cantor found that it failed when applied to infinite collections of numbers. That's what it was. So it was just about, it's not about anything.
I know, I've heard that argument before, that you have different kinds of infinities. You know, as far as I'm concerned, you know my position on infinity. I think it's an absurd suggestion. Because, you know, even if you wanted to count to infinity, you would need an infinite time and infinite energy, and you know, and all these things just don't make any sense to me, Dale, since my world is pretty finite, including my lifespan. So I think Cantor's had his head up his arse, and while these things might be useful mathematical tools, I don't agree that they jive with reality.
No.
The typical example they bring up is fractals, so that, you know, if you were to try and measure the coastline, then depending on how far you zoom in and how small you go, you're always going to, you know, get bigger and bigger distances, right? Because you're zooming in, you know, to try and measure a coastline. But, you know, as I say, for me, that's mathematical trick. I think that would go maybe too far at the moment to discuss that. But
it's an abstraction. It's in numbers. It's in language. It's not in, you know, tangible, objective reality, is it?
No, it's algebraic manipulations, using set theory. So But anyway, just to go back to this one, so these were, if you like, the things that Euclid said are universal ideas. Everybody can agree to these statements as soon as they understand the meaning of them. And what he went on then to do is say, well, here are my axioms, and basically there's 5 of them, that from every point to every other point, a straight line can be drawn, right? Which I think is absolutely intuitively true. I deny or I challenge anybody to not be able to do that. Yeah. A limited straight line can be produced continually. So if you've got one small segment of a line, then you can theoretically extend the end as far as you want, and it will always be a straight line. You can choose any center and choose any radius, and you can draw a circle. So everybody knows that circles are also, you know, they have the same proportion. It doesn't matter how big your circle is. The ratio of circumference to diameter is always a constant, at least on a plane. We know that's not the case on a sphere. And all right angles are equal to each other. So, you know, if you hit one perpendicular, as you were saying about the experiment, if you attach, you know, everything, you know, flush to one original perpendicular, then all the right angles are going to be equal to each other, right? Now, there was a huge challenge at the time because the fifth axiom here is something that's not necessarily intuitively true, and it has to do with parallel lines. And the formulation of it is actually quite strange, you know. If a straight line falling on two other straight lines, then the angle towards the same parts less than two right angles, and the two straight lines being indefinitely produced meet towards the parts where the angle is less than two right. So I'm not even going to read it out because there's been so many different definitions of number 5. And basically, if you take the axiom number 5 and you reword it, then that's how you change planar geometry into Euclidean, into spherical or hyperbolic geometry. It's basically just a manipulation of these axioms. So that's where the formalism comes into it. And if you take a different definition of what a parallel line is, then you can go into a wonderful mathematical hyperland, right? Of stuff that has nothing more to do with your reality. You cannot possibly tell me that an axiom that has a different definition of parallel lines that I see in my reality all the time is the true one. Then that's nonsense, right? That's where they'll take us off into curved space-time and you know, all the kinds of nonsense. So you can see that Euclid basically said, here are things that are absolutely obvious that everybody can prove for themselves. The fifth one was a bit contentious, and people have tried to prove the fifth using the first 4. But even Euclid didn't use the fifth axiom until I think book 7 or something like that. So the first 6 books, he just used these first 4 things to deduce everything. And it was only at some later point that he actually used this axiom in one of his proofs. And people thought for a long time that there must be a way of proving the fifth from the first 4. And basically in that they played with that parallel postulate, that's how these other mathematics were created. But just because you can make, you know, something on paper and make a definition doesn't make it true, right? It doesn't make it real. So I just wanted to show that to people. You know, that's basically, that page here is where Euclid basically developed a whole geometry that works today, that's worked for whatever many years you want to believe that we've been here, and is used daily to this very day in everything that we do with engineering and construction.
Yep, and it will continue. You want me to play this Khan Academy one?
There you go. I haven't seen it, so
we'll be listening to see what it's saying. Let me see here.
Usual stuff, fair use and all that.
Yeah, fair use, educational purposes, public commentary and all that stuff, whatever. Again. Okay, so
Euclid of Alexandria, who was a Greek
in fact, hang on a wee second. Has that jumped to that one, Gav, the Khan Academy one, aye?
Yeah.
Right.
Laws of nature, but the mathematical thoughts of God. And this is a quote by Euclid of Alexandria, who was a Greek mathematician and philosopher who lived about 300 years before Christ. And the reason why I include this quote is because Euclid is considered to be the father of geometry. And it is a neat quote, regardless of your views of God, whether or not God exists or the nature of God. It says something very fundamental about nature. The laws of nature are but the mathematical thoughts of God.
The design of nature.
Math underpins all of the laws of nature. And the word geometry itself has Greek roots. Geo comes from Greek for earth.
Metri comes from Greek for measurement. You're probably used to something like the metric system. And Euclid is considered to be the father of geometry, not because he was the first person who studied geometry. You could imagine the very first humans might have studied geometry. They might have looked at two twigs on the ground that looked something like that, and they might have looked at another pair of twigs that looked like that and said, oh, this is a bigger opening. What is the relationship here? Or they might have looked at a tree. They might have looked at a tree that had a branch that came off.
Not, you know, real world stuff. No looking up at the fucking sky.
At a branch that came off it like that. They said, oh, there's something similar about this opening here and this opening here. Or they might have asked themselves, what is the ratio? Or what is the relationship between the distance around a circle and the distance across it? And is that the same for all circles? And is there a way for us to feel really good that that is definitely true? And then once you got to the early Greeks, they started to get even more thoughtful, essentially, about the geometric things. When you talk about, you know, the Greek mathematicians like Pythagoras, but why? Who came before Euclid? But why? The reason why Euclid is considered to be the father of geometry, and why we often talk about Euclidean geometry, is around 300 BC. And this right over here is a picture of Euclid painted by Raphael. No one really knows what Euclid looked like even when he was born or when he died. So this is just Raphael.
As I say, you know, these narrative parts, you know, we're not taking any of that as factually accurate in any way, shape or form.
Impression of when
just one thing, Dale, right at the beginning of this video, they were talking about, you know, mathematics being the thoughts of God and that kind of stuff. And, you know, I'm not on board with that. You know, mathematics has hung itself up to be some kind of divine, you know, science that underlies the whole of nature. But no, it's a man-made language that we're using to try and describe the things and the phenomena of nature, right? It's not something that is a priori there, even though philosophers and mathematicians would like to argue that. At least that's my opinion.
Exactly. Well, it doesn't exist objectively, does it? You know, it's, as you say, it was created by man.
Euclid might have looked like while he was teaching in Alexandria. But what made Euclid the father of geometry is really his writing of Euclid's Elements. And what the Elements were 13 volumes of essentially a 13-volume textbook, and arguably the most famous textbook of all time. And what he did in those 13 volumes is he essentially did a rigorous, thoughtful, logical march through geometry and number theory, and then also solid geometry, so geometry in 3 dimensions. And this right over here is the frontispiece for the English version of, or the first translation of the English version of Euclid's Elements, and this was done in 1570. But it was obviously first written in Greek, and then during much of the Middle Ages, that knowledge was translated into Latin, and then obviously eventually English. And when I say that he did a rigorous march, what Euclid did is he didn't just say, oh, I think if you take the square of one side of a right triangle, the length of one side of a right triangle and the length of the other side of the right triangle is going to be the same as the square of the hypotenuse, all of these other things. And we'll go into depth about what all of these things mean. He says, I don't want to just feel good that it's probably true. I want to prove to myself that it is true. And so what he did in Elements, especially the 6 books that are concerned with planar geometry, in fact, he did all of them, but from a geometrical point of view, he started with basic assumptions. So he started with basic assumptions, and those basic assumptions in geometric speak are called axioms or postulates. And from them, he deduced other statements or propositions, or these are sometimes called theorems. And then he says, now I know if this is true and this is true, this must be true. And he could also prove that other things cannot be true. So then he could prove that this is not going to be the truth. He didn't just say, well, every circle I've said had this property. He says, I've now proven that this is true. And then from there, we can go and deduce other propositions or theorems. And we could use some of our original axioms to do that. And what's special about that is no one had really done that before. Rigorously proven beyond a shadow of a doubt across a whole broad...
Rigorously proven beyond a shadow of a doubt.
Sweep of knowledge. So not just one proof here or there. He did it for an entire set of knowledge that we're talking about, a rigorous march through a subject so that he could build this scaffold of axioms and postulates and theorems and propositions. And theorems and propositions are essentially the same thing. And essentially for about 2,000 years after Euclid, so this is unbelievable shelf life for a textbook, people didn't view you as educated if you had not read, if you did not read and understand Euclid's Elements. And Euclid's
So, you know, in this day and age, nobody's educated properly then. Because as one of the last kind of street interviews that I done, Gav, I don't know if you remember it, you know, and I spoke to the three lads who are, you know, involved with, I can't remember what they said, engineering at space.
Astrophysics or something, wasn't it? Yeah.
And I asked them if they'd heard of Euclid and Euclid's Elements, and they'd never even heard of it.
Yeah, which is, you know, yeah, what can I say? That's a testament to our education system. The people at university don't know who Euclid is. Yeah.
But yeah, you know, back in the day, supposedly you were never considered as educated unless you understood these things. But today,
I mean, it would have been a part of that quadrivium, right? You know, you got the trivium, the grammar, logic, rhetoric.
yeah,
Then you got the quadrivium, which would have been geometry, which is basically Euclid's Elements. That's what they would have taught. And then arithmetic, astronomy, and music. Yeah,
exactly. You know, and it's a total opposite today. These students have never even heard of it.
no,
So-
you just dive head first into cosmologies and you know, whatever, astro balls, astro space ball science. Right?
Abstract, you know.
Yeah, or abstract algebra. You know, I mean, that's gained a foothold. It was considered actually in that time around the 1700s that, you know, that's where geometry kind of, it was still being used in all the world of construction, but where algebra started to get a foothold on the continent.
Yeah.
So a lot of the continental mathematicians, you know, started to use algebraic equations, you know, substituting generalized variables for things and moving into this land of induction rather than actually using physical constructions, using geometric principles that you could actually, you know, deduce from known facts. Yeah,
Yeah, exactly. I liked Billy Connolly's wee take on algebra. You know, Connolly, what's two B's? a couple of B's? I don't know. I must have been absent the day they gave out the B times table. You know.
right enough.
Elements, the book itself, was the second most printed book in the Western world after the Bible. This is a math textbook. It was second only to the Bible. When the first printing presses came out, they said, okay, let's print the Bible. What do we print next? Let's print Euclid's Elements. And to show that this is relevant into the fairly recent past, although some would, you know, whether or not you argue that about 150, 160 years ago is the recent past, this right here is a direct quote from Abraham Lincoln, obviously one of the great American presidents. I like this picture of Abraham Lincoln. This is actually a photograph of Lincoln in his late 30s. But he was a huge fan of Euclid's Elements. He would actually use it to fine-tune his mind. While he was riding his horse, he would read Euclid's Element. While he was in the White House, he would read Euclid's Element. But this is a direct quote from Lincoln. In the course of my law reading, I constantly came upon the word demonstrate. I thought at first that I understood its meaning, but soon became satisfied that I did not. I said to myself, what do I do when I demonstrate more than when I reason or prove? How does demonstration differ from any other proof? So in Lincoln saying there's this word demonstration that kind of means something more, you know, proving beyond doubt, something more rigorous, more than just simple, you know, kind of
Practicality. You know, water doesn't bend. There's a demonstration. Verify it for yourself or falsify it. You know, self-evident demonstration of the natural world.
Well, I mean, that's the difference, right? You know, if you pick up a compass and a ruler, then you can actually demonstrate that construction. You can actually go through the different, you know, positions with your, you know, body, with your instruments. But if you're just using mathematical equations still and writing down, you know, X and B and A and Y and Z, right? That is not demonstration, right? That's the difference, yeah.
Exactly.
Something or reasoning through it. I consulted Webster's dictionary. So Webster's dictionary was around even around when Lincoln was around. They told of certain proof beyond the possibility of doubt, but I could form no idea of what sort of proof that was. I thought a great many things were proved beyond the possibility of doubt, without recourse to any such extraordinary process of reasoning as I understood demonstration to be. I consulted all the dictionaries and books of reference I could find, but with no better results. You might as well have defined blue to a blind man. At last I said, Lincoln, he's talking to himself. At last I said, Lincoln, you never can make a lawyer if you do not understand what demonstrate means. And I left my situation in Springfield, went home to my father's house, and stayed there till I could give any proposition in the 6 books of Euclid at sight, so the 6 books concerned with planar geometry. I then found out what demonstrate means and went back to my law study. So one of the greatest American presidents of all time felt that in order to be a great lawyer, he had to understand, be able to prove any proposition in the 6 books of Euclid's Elements at sight. And also, once he was in the White House, he continued to do this to make him, in his mind, to fine-tune his mind to become a great president. And so what we're going to be doing in the geometry playlist is essentially that. What we're going to study is we're going to think about how do we really tightly, rigorously prove things. We're essentially going to be, in a slightly more modern form, be studying what Euclid studied 2,300 years ago.
And that's certainly no fucking bendy water, you know?
Absolutely.
So I'll just stop that because you know that wee couple of paragraphs there's taken from the thing I was reading out earlier. I'll maybe continue that. We'll see. So I mean,
but I find that I never knew that Lincoln was a fan of the elements. I certainly know that a lot of the other American presidents, Adams and Jefferson, and people like that, actually based a lot of their constitution. I think the Constitution of America starts with these self-evident things, right? It actually contains those words in it.
Yeah.
And obviously they had, I think, a lot of the scientists of the 1700s had a great influence on the American history, let's say, and the American Constitution.
Thomas
Because
Reed.
I know for a fact, one of my favorite guys, Thomas Reed, who taught Euclid's Elements at Glasgow University and at Aberdeen University, he's held in extremely high regard in America by Adams and Jefferson and people like that. And, his book, The Inquiry into the Human Mind on the Principles of Common Sense, is actually one of the books that the Supreme Court used to actually say how they judge of things, right? So you've got the judges in the Supreme Court, and what's their reference book? It's the Principles of Common Sense from the Scottish philosopher Thomas Reid, who taught Euclid's Elements, right? Yeah. I mean, that's how fundamental this stuff is, right? And people need to grasp that, the whole of the modern world's built on it to hell,
It's not been maintained right enough. Now it's fucking contorted and bastardized into utter fucking nonsense and garbage, but it's foundation. Yeah. Back
then it was still correct. I think today the Supreme Court might be, looking at the Daily Mail and making up their mind. I don't know.
Aye. Swayed by propaganda. No critical thought required.
Where, yeah.
Exactly. Let me just check. I don't know if I had anything else up there. It was just some similar geometry in ancient times. It's a wee 3-minute one. I don't know if we want to get through that quick.
Go for it. I think if that's the last wee clip, why not?
Yeah. Let me see.
Was it known or used in ancient times too? Well,
the smart card reader makes card payments easy.
Pain in the ass.
No fixed contract.
first of all,
well, sorry, just to stop it. Doesn't that just about say it all, You're trying to get an education, but all you get is advertisements and more debt.
Exactly.
2 Greek words, geo and metrein. Geo means earth and metrein means to measure. So you can say geometry appears to have originated from the need for measuring land.
So, measuring land, geometry, measuring land, applying plane principles. Again, I'm just going to keep saying this, ram at home, it doesn't apply to a curved surface.
Tell how old geometry is. The Great Pyramid of Giza was built around 2560 BCE, a little more than 4500 years ago. If you see, its base is almost a perfect square. The four side faces are triangular in shape.
They take the base as a square. Now imagine you build square walls off the square base and you want to extend it, 10 miles in any direction. You're going to keep using the same principles and everything will work and everything will be structured properly and will stand and would have stood for the same amount of time. So, none of this, it's just locally flat. Well, once you get out to a point where you're starting to have a drop away beneath you, you're going to see that gap, the structure's going to be compromised, it just wouldn't work. Any constructor knows that.
And are also congruent. In ancient Egypt, whenever the river Nile overflowed, it wiped out the boundaries between the adjoining fields years ago. This architectural marvel, named El Castillo, was built during Maya civilization. Could Mayan people make this more than 3,000 years ago without any knowledge of math or geometry? Well, of course not. Indus Valley civilization that dates back to 3000 BCE had parallel roads, house made of perfect cuboid bricks, and everything was well planned and measured. So, even very ancient civilizations had knowledge of geometry.
So when I hear this kind of new age, new modern type sacred geometry, this mystical bullshit, for me this is the sacred geometry. These postulates, what's applied in the real world, no some metaphysical, mystical nonsense.
But they didn't leave behind any complete record for us to tell us what and how much they knew. Now, date-wise, BCE stands for before Common Era and BC stands for before Christ. And they both mean the same thing. So don't get confused when BCE or BC is used to indicate the olden times. Later came the Greek civilization. Many Greek mathematicians like Thales, Pythagoras, and others contributed a lot to geometry. It was Thales, a Greek mathematician, who gave the proof of the statement that a circle is bisected, that is, cut into two equal parts by its diameter. And the famous Pythagoras theorem was proved by his student, named Pythagoras. But all the knowledge could have been lost again if this great person, Euclid, hadn't collected all the known work and arranged it in his famous treatise called Elements. Elements had 13 chapters, each called a book. These books have influenced the whole world's understanding of geometry for generations. We shall discuss Euclid's approach to geometry in the next class. Until then, bye-bye.
Bye now.
So I think maybe just a bit of repetition there, but still,
just
well worth hearing that, it's not just us saying this, this is known fact still, right?
Yeah.
It's known teachings, it's known applications of that geometry, and it's used today, so it's not just, two guys hallucinating here, right?
This is it, again, everybody's talking about measurement and science, and we're not seeing any of that. As I said, I put it in the bottom of this, the Earth's been measured. It's been measured for all this time. People are running about with optical devices, making assumptions, making statements and assertions based on a purely visible phenomena, ignoring the practical, actual, tangible measurement of the Earth that's being used every single day. The visible phenomena is not a match for the practical, actual, measured, everyday reality, So it is repetition, but I just want to keep ramming it home. There's absolutely no way for these people to escape it. They have to come up with ad hoc excuses and bullshit, just to try and evade it and prop up this fucking stupid image.
Yep, I fully agree. And people need to understand that, again, I'm going to repeat myself too, but definition of mathematics being basically a doctrine about how to measure the quantities of things, right? I just maybe want to share my screen one more time because I feel this is very important, is actually to understand what a real quantity is, right? So, you know, quantity is something that you can actually measure, but it has to be measured by its own kind, and it has to be made of similar parts, right? And this is a definition that I like, that is very simple. You can, what is made up of similar parts may be measured by its own kind, and what is measured by its own kind must be made up of similar parts.
Yeah.
So, you know, if just that one sentence, if people really think about it, then they can start to understand that when Euclid, for example, starts to define what a line is, we can see lines everywhere in nature.
Yeah.
We can see surfaces everywhere in nature, right?
Yeah.
And we can see volumes everywhere in nature.
Yeah.
And that is basically what the elements are all about: lines, surfaces, and volumes. And all of these things, they'll have to do with real substances, real stuff, right?
Yep.
Not visible stuff, not stuff that we can't see, not, you know, stuff that is, you know, apparently measurable, but,
Yep.
you know, we're in no position to actually physically touch it, smell it, knock it, taste it, none of that, right? And that's the big difference. You know, we need to really pull science back and have a common sense audit of what they are actually measuring and what they think they're measuring and what they tell us they're measuring. Yep.
Yeah.
And that's where, you know, when they start to invoke all these visible proofsies that, you know, I have a real issue with, because partial perceptions, as we know, is no way and any way trumps our full perceptions of real substances in the real world.
Exactly, which, you know, brings me to a point. I had an email from the channel, Dr. John D, who I think is apparently some PhD in, is it spectrometry? I think, is that the right definition of the word?
Spectrophotometry, I think, yeah.
Who's postulating some sort of experiment and wants it peer reviewed. So I'll send the email back and say, aye, of course, but, you know, again, we're talking about first principles here and where we start from. I start from an understanding of the geometry. I start from knowing the behavior of a substance like liquid before I get to a point of a purely observed phenomena, because it's not properly measurable. And I don't really require that to understand that I'm on a plane. So, you know, I agree that, you know, we'll have a look at the results and what goes on, but in no way, shape or form am I going to take any of it as conclusive proof of anything.
Yeah, so I'd just like to confirm that. I'm the same, Dale, that I don't need an experiment with lasers or anything else to tell me that water can't bend. Yeah, that for me is a self-evident truth, you know, part of my lived life. Yeah, and something that I really know. Yeah. So, but yes, if somebody is wanting to make a visible experiment, let's say with lasers, and try to show that this in some way proves for them at least that water doesn't bend, then hey, go for it. Yeah, I personally don't need it. It might tell us something about the way light works, the way vision works, the way the atmosphere does things, right? Yeah. And all those, you know, that inexact science that we still have around all of those things. So, and as far as I'm concerned, kudos for anybody who's investigating that. But I don't need it to tell me that, you know, water can't bend. That's just
no. It's trying to measure a visible phenomena. It's no measurement of the actual Earth in any way, shape, or form. What we've just pointed out is that the Earth's been measured, and it is every single day, and it's practically applied. So I'm the same as Gav. I appreciate being given the shout to be involved in something. I really appreciate it, and again, kudos to anybody who's endeavouring to try and further their understanding. So I'm on board with that. But again, you know, just to say, for me, it's not going to be conclusive of anything. You know, what's conclusive is what we've just shown, these elements, and, you know, the applications in the real world. That's undeniable. It's already measured. So
maybe I'll just show the website, Dale.
Yep.
Of what this guy's going to be doing. Let me just share the screen. He set up a website. His name's Dr. John D. It's a website called Peer-to-Peer Experiment, I think. I'm just going to share my screen now. It's just reacting a bit slow, but for people who maybe haven't seen this. But can you see my screen?
Yeah, I'm just going to That's you.
Yeah, so it's called peer-to-peer, which I think is a play on words, because he would like a peer-to-peer review by, not only flat earthers, but also globe believers, yeah?
Yeah.
And he's basically set out a method and a variable and the equipment that he's going to use to make a visible observation. Then just of it basically being shining a laser through a copper tube, and a camera also set up at 1 meter above the surface of the water. And the idea is to see whether you can see this or not, taking in various variables like tides and things like that into it.
Yeah.
Now, from what I can see, he seems to be following the scientific method. But, I have an issue with the scientific method, because the scientific method involves the distinction of what quantification means, right? So when people say they are measuring things, then quantification means they have to map it to my sense observations and my phenomenal experiences.
Yep.
And that's where I find that, there's a problem in the mathematics of things, right? And I also, we've said this a couple of times now, but this is a visible experiment.
Yep.
And not a physical experiment, yeah? And it needs to be declared as such. And we're doing that right now to make sure that people understand the difference. And I don't need it, but sure, let's, I'm also willing to look at what the guy's done after and make my conclusions from it, but it's not going to tell me whether water bends or not.
No.
I already know it can't.
Exactly. The practicality of everyday lived life tells us that it's no bending. And again, the elements that we've just shown, the Earth already is measured. It's been measured every single day, and it's applied, and it works, and it's known. But if this helps anybody in any way, shape, or form, it might, as you say, Gav, add to the knowledge of the eye and vision and light, and that's it. But it's, as you say, it's a visible phenomena. It's not a measurement of the Earth in any way, shape, or form.
And again, you have to believe in spectrophotometry, right? You have to believe that it's possible, to irradiate materials with light of different frequencies, measure it against a reference beam, and use typical diffraction gratings to say, well, okay, that means it's made up of this and this substance, for example, right? That's where it's used in chemistry and biochemistry and biology, right? And astronomy as well, the same principles are applied. So I have an issue with the overall science behind spectrophotometry, because, I don't necessarily believe that the quantification of it is correct in its current form. But again, it's just my opinion. People should take what they want.
Exactly. And again, we're in, I want to look at it. I appreciate being included in it. So thanks to Dr. John D for that. I'll send an email just to confirm properly, though, in case he misses this or doesn't get a message through this anyway. So
I think he invited people to come down and watch the experiment happening. I think it's the 1st of February. Right. I won't be taking part in that, but I would be interested in seeing the results. But I'm sure he'll publish them, right? If he's going to do a peer review, then I don't want to be part of some little clique or group, Dale. As far as I'm concerned, it needs to be peer reviewed by the whole of humanity, right? Yeah. And just any select people. Yeah.
That's it. I gave an example the other day that everybody can peer review. Every single person. They don't even need to leave the home, to understand how water behaves. So, I'm the same. But if it's not too far away and I've got the funds, I might take a wee trip down just to see who shows up and see what's actually going on. So.
Aye, you might send them into frenzies, Dale, if you turn up there.
Aye. So, what else can be said about what we've shown here, Gav? I mean, it's pretty clear, is it not? If we were living on a ball, none of that stuff would work.
Yep, no, absolutely. I mean, the one thing that, I still, if there's a question around this whole Euclid's thing, then the question I would ask is, okay, Euclid put 4 axioms out there. He says they're self-evident. How did he think of them, right? Exactly what was his thought processes in writing those 4 down or these 5 down, right? And, the question that I ask myself is that one. And I would say to myself, well, Euclid must have just looked around in the world, right? Yep. Seen, for example, that water is always flat and planar, right? Seen that, for example, two different elevations of water are also parallel lines, for example. Maybe he thought about how his eyes work and that he always sees a flat horizon and a circle around them, right, when he was using that one. So, you know, my presumption would be that as a sentient being, discovering his reality, he's used the self-evident truths that he experiences, right, and he's tried to formulate them into those four. And I don't think I could do a better job. I don't think anybody could. And the guy's proven that it works, right? Exactly. So, you know, in that respect, you know, that's maybe one of the kind of questions I have. How did he think about these things? But it's not really material to what we're talking about. It's just my own.
No, but it's true, and it's I think pretty important as well. Just as you say, point out, you know, if you're making a language, you know, as we've always stated, for me, maths is a great tool, and you stated it earlier. When it's applied to real substance, real tangible, real world examples, it's a wonderful thing. You know, we can use it and speak to each other with it and construct and come up with all sorts of practicality. But that's where it has to be. As soon as it's left the practicality into the realms of abstract and, you know, it's no falsifiable or verifiable, just built in the realms of imagination, it's fucking useless, you know? So. And
I'd maybe just like to point out one other thing there too. So Riemann, the how should I say, the protege of Gauss, Mr. Curvature, his most famous paper, and the one that transformed the whole world of thinking about geometry into spherical geometry, his paper was called On the Foundations, or on the Hypothesis that Lie at the Foundations of Geometry. So he was thinking about exactly that. What's the foundation of geometry? Not just the four axioms of Euclid, but as far as he could see, what are the foundations? And that paper was something that transformed the world then after that, right? Riemannian geometry and the sphere, you know, the whole thing really took off after that paper.
Non-Euclidean.
Yeah, sorry, non-Euclidean, yeah, no, sorry. But there was also other people doing it. So there's a little known paper from a German physicist, or it's actually a medical doctor called Helmholtz, the guy that discovered the ophthalmoscope. Yep. And how, you know, the thing that opticians use to look into your eye. Now, Helmholtz wrote a paper, and he lived at the same time as Riemann, and they were actually, you know, if you like, contrahents in a certain way, because Helmholtz wrote a paper, and his paper was called On the Facts that Underlie the Foundations of Geometry. Riemann's was called On the Hypothesis that Underlie the Foundations of Geometry. So you had two opposing people. That Helmholtz was looking at it from a physiological point of view, how geometry works, and Riemann was hypothesizing, right? Yeah. And if you like, that for me is the nub of the whole problem in some way, right? Yeah. You know, if we come, you know, I much prefer Helmholtz's paper to Riemann's paper, even though the one, you know, and I would urge people just to look them up, you know, Helmholtz geometry or Riemann geometry, and compare the two, and they'll find, you know, a huge difference. There's one man arguing more for physiological facts because he was a medical doctor, and about how geometry should be based on factual knowledge of the real world and how you are constructed. And another guy saying, oh, I'd rather hypothesize about it, and make up stuff and make up models. Mm-hmm. And you can see the two differences in the mathematical approach. Sorry, I just wanted to throw that in. It's an interesting read, I think.
And it was the latter that took hold and, you know, brought us the fucking globe nonsense.
Unfortunately,
the whole cosmology, not just the fucking globe. Heliocentrism, you know.
Well, the whole religious cult that we all born into, right? I mean, it's so difficult for us to see it when we're born into it, right? I mean, it's taken most of us a lifetime to wake up from the indoctrination, and it shouldn't be that way, Dale. You know, I mean, we should be getting those facts a lot earlier in life, right? We should be able to discern, but they're just bombarding us with propaganda and misinformation and imagery, right?
Yeah. Well, I had a wee idea that I'm going to do some sort of activism. I'm going to phone round some engineering firms, and I'm going to ask questions, see if they're up for, you know, taking part in a wee scientific collection, and ask them if they understand Euclid's Elements, the applications, and they agree that that's the applications that they're actually using in everyday reality, which we know they are. But just to gather information on whether they really understand it and, you know, whatever else. And then obviously put the question to them, well, if you understand, you know, these things, you're applying them, you understand you're not on a curved surface then, you know? So we'll see how it goes.
Absolutely. I've had a few experiences with that myself, you know, at a couple of engineering offices or construction, asking the same questions. And I was met basically with a kind of disbelief, of course, you know, as usual. A lot of engineers were, you know, they came back, well, oh, I don't really understand that higher mathematics. And but no, we don't use it, you know, but I'm not sure to say one way or another. Do you know what I mean? So even if they're applying it in real life, Del, they're really hesitant to admit it, right? Because they're still so conditioned from the white coat authorities or the images on the TV screen. You know, it's astounding.
Well, that's what I put in the book. That's what I put in the book. That's the description. It's exactly that. The conflict, the confusion comes because of this fucking image. You know, if it wasn't for that image and TV screens, there wouldn't be any issue. These people would commit to it. They would know it. They would agree. Yeah, of course, of course, of course. But that's what the conflict is. They're confused only because the power of the TV. You know, because they've never applied it. They've never witnessed it with their own practical applications, their own eyes, their own experiences. Nothing. You know, everything tells them they're on the level. Water runs fucking downhill. It collects, it equilibrates, and it's a fucking planar surface every fucking way. But you know, I don't understand my vision, and I see it in the television, so therefore, I don't know. You know, it's pathetic, but understandable, but pathetic all the same. You know, but can't hear you.
Sorry, it's just a sad state of affairs, Del. Yep, that the world is in that state. You know, that, how should I say, all as grown men with the faculties that we have, you know, are denying, you know, our reality in favor of switching it for some image or some authority. You know, I mean, it's a sad state of affairs.
Yeah, exactly, mate. So, I mean, I don't know what else you want to add to this. We'll just keep it on that topic.
Yeah, no, I think maybe let's stay on this topic. I've just got maybe just one thing that we were talking about earlier: plain sailing. Yeah. I'd just like to maybe just show
that
the definition of plain sailing, because I thought this was quite relevant to all the people who say, "Oh, but navigation only works on a ball." I don't know. Can you see the screen?
Yeah.
Yeah. So plain sailing is sailing a ship or making the arithmetical calculations for so doing on the assumption that the Earth is perfectly flat.
Yeah.
Where have we heard that before?
Yeah.
That all meridians are right lines parallel to each other and perpendicular to the equator, while the parallels of latitude are right lines equal and parallel to each other and parallel to the equator.
Yeah.
The lengths of the degrees on the meridians, equator, and parallels being consequently assumed as all equal.
And anybody who is old enough would remember, you know, using road maps, atlases, and that's exactly what the layout was, which is what is just described there. That's what you were using before you gave it up for your wee fucking colourful TV screen that was telling you were on a fucking globe.
Yeah, I mean these definitions here is basically just a rectangular grid, exactly like a map. Yeah.
Yep.
This one.
Sorry, hang on.
The same annoyance as last time, is it?
Yeah, that's it. Carry on.
So it goes on to say here that it is not a strictly correct supposition. Well, no, I'm getting it as well. Hold on, I'll be back in a sec. Just let me get rid of that. Okay, I've just shut it down so that we don't get interrupted. Yeah.
Cool.
Yeah, so it goes on here to say that it is not a strictly correct supposition to take any part whatever of the Earth's surface as a plane, yeah? Yet when the vessel goes on short voyages, the results obtained by plain sailing will be sufficiently correct to serve every useful purpose, right? So basically, plain sailing may be considered as the application of plane trigonometry to the solution of plane triangles where the hypotenuse or longest side is the rhumb line on which the vessel sails, yeah? there's one other that I think is important. So it says here, plain sailing cannot always be advantageously employed, although in practice scarcely any other rules are used but those derived from plain sailing. The great and serious objection to plain sailing is that longitude cannot be found by it accurately, although in practice it is more frequently found by it than by any other method, right? So, you know, just to make clear, we can talk about all these other things all we want, Dale. For all practical purposes, everybody uses planar geometry and plain sailing, yeah?
Exactly. Yeah. Same as you know, flying an aircraft. Same assumptions are made. Same geometry is assumed and applied. So,
yep.
It's about time these reality-denying morons accepted the factual, self-evident reality that we're living in and stopped playing silly games, you know, zealotry to try and maintain this idiotic cult belief in a nature-defying testicle.
Yep, the potato rock.
Gear up, lads.
Well, I mean, they just keep coming back with the same stuff. You know, I hate to repeat myself, but it's all the same visible proofsies. You know, all the stuff is all related to visible geometry and not to physical geometry. And you know, I just urge everybody, if you want to have an objective look at the real world, then the objectivity will be found in the physical substance and the nature of our reality, and not looking up at the sky at visible objects and having some kind of subjective opinion on what you think they might look like or what you think space is, or, you know, any of those words, right? People really need to be rooted in that knowledge. They need to be secure in that knowledge, because all of us, Dale, all of us throughout history, throughout all of time, everybody who's ever lived is having the same experience as me and you right now.
Exactly, mate.
Right? There has been no other one.
No.
Yeah? Maybe for 500 people that apparently went up in a tin can. Yeah, right. Yeah. Or for mathematicians, you know, lost up their own arseholes thinking up cosmologies. But for every real person in this real world, nothing changes every day you wake up.
No.
It's still flat. It's still Euclidean.
Exactly. It's going to be the same for the foreseeable future, you know? So the two geometries, as Gav was saying, the physical, real world, Euclidean, plane. The spherical, visible world is not an exacting science. It's not measured properly. There's loads of grey areas, things that have to be understood. And these people, you know, that's the difference. We, you know, people who refuse the globe are looking at the real, you know, objective, measured world. These people are just looking at the visible world and making assertions based on utter fucking nonsense, cherry-picked to suit their bias. It's preposterous, and it should be abundantly clear and obvious now. The defining lines should be coming really clear to people about what's actually going on here with these two geometries and how they've interchanged it and tried to push it forward as a fact. It's just not a fact, you know?
That's exactly right. And don't get me wrong, I mean, I don't want people to think that I deny visible geometry. I find it a fascinating subject, right? Worthy of a lot of analysis and research and exploration, you know? But it's got nothing to do with the ground underneath my feet. Yeah.
Exactly.
Period. Yeah.
So when you get these idiots saying, "Oh, so scientists for thousands of years were all wrong," yeah, you think it's no a ball? No, all these scientists knew it was a fucking plane. So you are the one that has to deny the thousands of years of known factual reality. No us. We accept it.
Yeah, they talk about these stories, how the ancients always knew it was a sphere and all that kind of stuff. But I think when they say that, Dale, what they're really saying is the ancients thought that we were inside a sphere and there was level water inside it and it had a dome, right? And they didn't know what was underneath. That was hell or purgatory or, you know, Sheol or whatever you want to call it, right? You know, so... you know, even when they bring that narrative, the ancients knew it was a sphere. Yeah, maybe they did, but they thought they were inside it, Dale, not living in the fucking outside of it. You know, so they like to spin these stories. You know,
and you can see that based on the celestial sphere. You know, that concept of the observer at the centre, because every single individual looks like that. that's the way the world appears to them, that I'm under my own wee dome. You know, so you see a lot of these depictions from the old cosmologies that depict something similar. And that's what I agree, Gav, you know, this nonsense about everybody thought it was a sphere. No, from the inside, on a level plane, you know?
Yep, that's the way I see it. It's only when they started to spin the fucker, Dale, that's when shenanigans took hold, you know? When somebody thought that if I spin a bucket of water, I can pretend with this false analogy that that's the way the world is working, and it's really spinning around and that's all stationary. What a lot of fucking bullshit, right? Just mathematical trickery. Yeah.
Exactly, mate. Exactly. But it's just becoming an apparent fucking, you know, joke. Yeah. So, you know, we'll keep hammering them.
Yeah.
You know? But hopefully people have got a real grounding and an understanding of the geometries now, what the real physical geometry is. And again, you know, for these people to say for thousands of years that they thought it was a globe, well, people like Euclid would never have put these propositions up. They would never have worked, you know, if he really thought it was a fucking sphere. These axioms just wouldn't exist. So.
Oh, spot on. I don't think I've got anything more to add at the moment, Dale.
No, me either, mate.
Another topic you wanted to discuss as well?
No, I'm going to save some of that for another one. People were asking if I was going to open up, but I'm no on OBS. I would have to open up another hangout in OBS and open up for the live. I don't know what people are saying in the chat. I think you know, just covering this and leaving it at that's probably good enough.
Maybe there's questions or something, and we can.
Any questions? Any denial going on? I'd be interested to hear anybody's denial of what's been offered to them here. You know, let's hear it now. Don't wait for the stream to end and then spew your fucking religious crap at us. You know? What you know, me and Gav are both focused on the chat, so I'm going to make a smoke while we're waiting for something to be offered. You know, we've obviously had some globe-tard trying to call us while we're on live, so, you know, why don't you pipe up and say what you've got to say in the chat box if you've got anything. Who are the flat earthers who have actually studied physics? Are there any at all? Philip, you answer, Philip. Have you got a problem with what's just been shown to you? Are you denying your objective reality? Cheers, Pat Mustard. Tanya, thank you. Doing a bit of yoga.
Hey, Del, maybe you want to put the phone on again if somebody wants to dial in.
Aye, that's a good idea.
Aye,
the phone is on.
Maybe just reiterate that number for all our viewers.
Yes, I keep needing to see it. Wait a minute. So the number for anybody is 07425 407 853. Again, we're interested in what anybody's got to say and what's been offered here. Acceptance, denial, reasons why. Let's hear it. What's that? Do you have any idea of the distance our eyes start to render things in 3D? Looking far, far away, the things are 2D image. Great work to you two, by the way. Are you still there, Gav?
Yeah, I am. Yep.
Did you hear that?
Sorry. No, I missed that. Sorry, say again.
Do you have any idea of the distance our eyes start to render things in 3D?
Well, any idea of the distance? Well, I don't believe that eyes can see in 3D.
No.
From geometrical principles, it's quite clear that, you know, it's only a two-dimensional image that we have, right? Of basically the altitude above our horizon and a longitudinal view left and right. So these are only two dimensions. There are such things as depth cues, which I think I've said, you know, multiple times, that because we have two eyes, there's a certain parallax angle. And because colors change when things are far away, then we have what we call depth cues. But monocular vision with any one of your eyes is not possible to distinguish between the size of an object and the distance. And anybody can prove this to themselves, right? You know, you can hold a coin at an arm's length and it will cover the size of the sun. Yeah. So, you know, these things are fairly clear and geometrically known. So, you know, another obvious proof of it is in physical space, no two bodies can occupy the same space there, right? You know, I can't, if I've got one object in a certain position here in this room, I can't put another object in the same position. But with visible geometry, you can. You can have two things overlapping in your visible 2 dimensions, right? And that's something you can do in 2 dimensions, but you can't do it in 3, right?
No.
So, you know, no, we don't have 3-dimensional vision. We have 2-dimensional vision.
Yeah, we move.
That's all.
Yeah, we move in 3 dimensions. Philip, what are you going on about? Anybody studied physics? You know, we're all studying it. We're all talking about it. If you get some point you want to make, you seem to be the only one here, but you're not really saying anything.
Is that knob asking, oh, he claims to have a degree in physics? You know, I've said this many a time, that everybody's a natural scientist there, right? We all have the same faculties, you know. It doesn't matter what bullshit or what conditioning you've been through. And I've been through a physics conditioning and a mathematical one, but it didn't help me discover the reality of this world. It's only looking at it from a common sense, practical, demonstrable viewpoint that you can discern the difference. So you can fuck your degree. Stick it up your ring.
Philip's trying to appeal to fucking stature and coming in with all that fallacious bullshit. You know, we're all scientists, Philip. If you get something that you're going to offer, or are you just trying to play linguistic games and assert your dominance in some way, but you're actually not saying anything?
No, he's not saying. He's just calling people liars, isn't he, without any real... Just a wee...
Philip, you're a joke, son. You've got an absolutely fuck all. You're a reality denier. I'm going to ignore any text you put unless it's in regards to the topic that's been discussed. What's been shown to you here?
Look, I'm actually thinking he can sway people in the chat by trying to, you know, talk about bits of paper, you know, as if it meant anything to me, as if it means anything to anybody here listening, right? It doesn't. You don't fucking need it to understand what's going on.
Yep, that's it.
Wank.
Exactly. You know, all that fucking old hat stuff's just not going to work. You know, you might sway some gullible with your appeals to consensus and authority and your uppity attitude and your linguistics and all that stuff, but that's not going to wash here, mate. Barking up the wrong tree.
He must be one of these new guys that they've thrown over the trenches. You better go to beyond the imaginary curve. Go and hassle them. Oh, fuck no, please, not me.
Yeah.
Over you go, son. Over you go, son. Do your best.
Exactly, David. Mark, tangible objects in your hands is when you can experience 3D. We move 3-dimensionally. You know, if people are making claims that it's not part of that 3-dimensional experience, then, you know, it's all conjecture. So you guys let someone hold up a piece of fuck off. Still don't have that piece of paper. Right, hang on, I think the phone's getting some messages here.
I'll be back in a sec, Dale.
Cool. Hi, Mark here, mate. If NASA know they ain't flying to the moon, what do you suppose they're doing, trying to recreate the Big Bang? If they really know there was no Big Bang, what are the hadrons really doing? Fuck knows, mate. Fuck knows. Are we trying to penetrate something above, something below, create some sort of field? I don't know. Nice one, Gar, for the presentation. Always learn something new, Mr. Cheswick. Cheers, mate. All right, Dale, can you text back so I know it's the right number? Sonny for Springburn and old Coolian. Cheers, bud. Can I text you back on this one, mate? No, this one's I've missed. I've been looking on YouTube to see how many people were using your voiceover images, and I found a lot of them. I still think it's a good idea. I just don't like the fact that it's been done a couple of times before. So thanks for your willingness to participate, and let's speak again soon, Siddy. Nice, no bother, mate. How do I get back? What the fuck? Right, where am I here? Philip, I don't know if you're missing it. All those fields of the practical real world take from Euclid's Elements. What are you talking about? They're all planar engineers and doctors. Are you retarded or something? We don't need to be paid to lie either, Tracy. You know, it's just a linguistics aspect. They're missing parts because they don't fully understand what's being shown to them. So no, again, you know, not everybody has to be actively lying. Again, people like us, we were not lying. You know, we just misunderstood aspects of ignorance. Philip, why are you here trying to bully us into your cult fantasy? We don't want to be part of your cult fantasy. We accept our reality, the objective reality, but we don't want to, you know, believe your concept. So stop trying to bully people into believing your crap, son. Is he the only one that's here? All the rest of them can't go at their tongue. What's going on? Exactly beyond belief. No, exactly, Bill, as well. No cults here, freak. Exactly, hope for truth. Questions for Del and Gav. Globe now, in a body of troops or of men or animals drawn up in a circle. Military formation used by the Romans, answering to the modern infantry square. Is that a question? Dean.
So I've heard, you know, I mean, a lot of the geometric principles was used very heavily in military applications, fortifications, you know, navigation, and so, you know, all these principles were applied there as well.
Yeah.
So but I didn't see a question in that chat. Sorry.
No, he's just ignoring it because he doesn't have anything. He's just trying to sway people with, you know, the usual illogical garbage. No, I've not watched it. I have no sphere. I've not had any time. It's very difficult for me to give any attention to these creepy wee cult morons, to be honest with you. As I say, I've seen Mr. Cheswick taking a clip, obviously, from his latest celebrity interview. Fucking gamer nerds talking about fucking imaginary concepts, you know, and telling people that they're going to keep making fun of them if they keep refusing the cult teachings of fucking lunacy. Craig's just an absolute bell end. You know, we're not interested in degrees and all that stuff, Philip. If you go anything higher, no, you know, obviously not. You're talking about people with 4 years engineering degrees. Well, go and ask them if they understand Euclid's Elements, the very things that they're applying in their practical engineering endeavours. Well, that's right. Oh, it's just locally flat. It only applies locally. How locally? How locally are you talking? You know, them that built the Channel Tunnel. Is that local? Huh? Where was all the bendy surface accounted for there and their engineering principles? Nowhere. Lizzie Magumba, usual, emotionally appealing. Well, this is how they do it. They play on character. You know, they put these personas out to try and get people and trap them on an emotional level. You know, while they spew their fucking garbage at them. Deceptive little nasty piece of shit. People like Krieger. He's beyond saying he's just confused. That wee Fandan is doing it deliberately. Exactly, Magumba. It's probably his own fucking stupidity. Well, as I say, Fresh 75, you know, I'll speak to anybody.
I see a question there from El Capchi to me.
All
So
right.
I've spoken to some of my colleagues from the university days. I've got one that knows that he's no longer on a ball.
Yeah.
But most of them are whatever. No, there's two of them that are professors of mathematics. They are not convinced yet, but I'm still discussing with them various things.
Yeah.
So yeah, a yes and a no is the answer to the question.
Yeah. Flats, I think all games are rendered on flat planes there. You know, it's the same principles that's applied even in the gaming world. You know, Craig would have to, people like that would have to actually deny their passions as well. You know? You'd be using some sort of Cartesian grid reference, you know, to project a 3D rendering. But the exact same. And I don't even know much about gaming, but I'm willing to take a guess that that's exactly how it's done. Right, Flatser, spot on.
A lot of mathematics in gaming, Dale. That's for sure.
Yeah. And you think they're making curved surfaces in their gaming worlds?
Well, it all looks so real, doesn't it? All based on these mathematical models. Yeah. So, but yeah, that's exactly where maybe the confusion comes. I pity the gamer generation, to be honest, a little bit. Although you know it has its fun aspects, and don't get me wrong, I've done some ego shooting myself in my time to try it out. But maybe that's one of the reasons that the gamers are so involved here, is because these fantasy worlds that they get to play in, you know, is an extra conditioning that I didn't really have. Right? It's a kind of later thing, right? But if you're born into it, maybe it's a bigger brain conditioning than we had, you know.
Aye, it's all Star Trek, Star Wars, gaming, all rolled into the same thing, you know. It's just warped our perceptions where they've now blurred the lines between fantasy and reality, you know, and then now they're on YouTube spewing their fucking crap at real sane people who are no part of that culty fucking nerd community, you know.
Yeah, it's really funny the way they keep coming and trying to want to drag us back, you know. I have no intention whatsoever of ever going back to believing that nonsense. And the thought that one of these guys thinks he can come into some chat room, right, and persuade me differently is just even a bigger reality denying than the delusion he's already living. Yeah, if he thinks he can sway people like that, it's unbelievable.
Nice one again on BTEC. Cheers for that. When the subject is laid out like this, I'm not sure how people can still deny it. Dr. John D seems to be pointing it out well in a way that he thinks he can make people understand it, but I am on board in that I don't really need to do any further checks to confirm what or Disney fucking bend. Nice one. Cheers for that. I don't know who it is, but no, Philip, if you want to make claims about physics, you practically demonstrate. Stop getting on, son. You've waffled on here time and time and still offered nothing. Dean Stewart, no bother, mate. Nah, no problem at all. He's asking Gav, I don't know if you reading that. Yeah,
I'm trying to, but I don't know whether my chat's really slow.
Dean Stewart, Dale and Gav, sorry, I have Asperger's. Tend to look into all things. Was just fascinated about that noun for the globe, re Roman army, and any relevance in mathematics. I thought you'd answered that.
Well, one of the things, if you look up a medical dictionary, then the globe is the old word for the eye.
Yeah.
Right. So in any medical dictionary, that's what they call it, a globe.
Yeah.
In the socket in your head. So, but any direct connection to the military, I still don't quite get the question, to be honest.
The military applications are, use the same principles that we've displayed here. Even a submarine, aircraft, boats.
Line of sight for missiles. Yep.
Troops on the ground, long distance sniper shooting. I mean, it's all uses the exact same thing.
Ground radar, LORAN, all the things that are backups for GPS. I was reading an article that was saying that GPS is inherently very fallible.
Yep.
So apparently you only need about a 1.5 transmitter to disrupt a GPS signal for about 30 miles. Right? You don't need much power at all. So the Navy and the military are pretty worried about the fact that, GPS is so unreliable, let's say, in terms of it could fail. Atmospheric conditions, spoofers, hackers, all that kind of thing. So you know what the backup is, Dale? So celestial navigation and plain sailing. back to the good old things, yeah. Tangible world and a bit of visibles thrown in. Yeah.
Get the Cartesian grid out on your fucking rectangle fucking piece of paper with your straight line ruler and fucking plot your direction. Yeah. That's
what they're saying now. Basically, make sure you take a sextant, a compass, and a ruler with you,
Yeah. John Samuel, 3Ds Max is one of the software they use to generate the imagery. I also use the software for architectural modelling. Interestingly enough, the software assumes a level plane. Of course it does. If it's going to be representing real world, then it would have to be, Beyond belief, Matt laid out over a curved table. As I laughed at before, how many of you have ever been lost in a cold dark night, back in the 90s, the 80s, and pulled out your wee globe? Oh, look, I'm doing this wee lane here.
And remember, Dale, the streets get narrower the further away they get. Huh?
Exactly.
And they come to a dead end where two walls meet like that. And then you can't go any further, right? It's like these games where you sort of bump into the end of your world.
I phone somebody for help. I get a telephone while I'm lost. All right, can you describe where you are? I am on this funny street. It's got lampposts that are big here, and then they get smaller and smaller the further away they go. And there's tiny houses away in the distance. I mean, does that help? Nah. Keep asking them, Gene. Somebody asking something. Never missed. Yep, Go Vegans Earth's a plane. Yep, CAD, Revit, SketchUp, all 3D design software I use that all base reality on a level plane. I wonder why, yeah. In a shotgun, they like to shout about sextants as if, they'll say a sextant, and they like to use these buzzwords, and then you actually ask them, well, do you understand the sextant and the applications of the sextant and how it's a plain geometric tool? And then watch them start mumbling and making excuses up and all this crap. How do you calibrate it? Oh, that's right, you calibrate it to the horizontal, no, the curvizontal. Yeah.
Are you sure it doesn't bend at the edges there just when it goes out of sight, Just when the visual limits are reached? I'm pretty sure it bends. That's when it starts, man. Come on. You must realise that.
Beyond the imaginary curve there, Gav, out there in the distance, It's fucking lunacy when I think about it. You know, just picture it. You're sailing away from the docks and picture yourself, you're going round and doing this. The docks are now behind you, run a curve. I mean, it's fucking absurd. Absolute nonsense, man.
Well, they never talk about how they get smaller and smaller when they go away as well, right? You know, I mean...
No. No.
But yes, on a formless ocean that is the substance water, it is very, you know, when you're out, if you imagine yourself right, really out in the water, no sight of any land, then of course you have the perfect circular straight horizon, right? Yeah. And I know that sounds strange when I say it, but it's straight, right? Anywhere you look at your vision, you're going to get it straight, and it goes round you that way. I mean, right? I don't mean it's like going over a curve, but
a planar circle. Yeah,
a planar circle, exactly the way Euclid defined it.
Yeah,
you can have a point in the middle. You can take any distance, and I can draw a circle. Yeah,
exactly.
That would jive with my reality.
That's it. No, I don't think we're getting anything from any of these people, Gavel, but the usual, you know. They'll wait until it's over and then spew an endless amount of fucking denial and garbage and insult and, you know, fallacious nonsense left, right, and centre. But that's about it.
Well, we've given them something to do. They can pull another wage for a month, or
aye, let's see them trying. You know,
whatever, indulge their fantasies or their habits or whatever's making them do this. You know,
aye, that's it.
They're absolutely irrelevant to the topic.
Exactly. Well, I think we'll just call it here.
Aye, it's been a good chat again. Always a pleasure.
Appreciate it, mate.
And thanks to everybody that listens and appreciates or supports. Getting about them. See you on the level, guys.
Cheers, Gav. Take it easy, mate. Well, again, thanks to Gav, everybody in the chat, everybody watching, moderators as always, much appreciated. Be back at the weekend. Maybe have a wee upload before that. I'll see how it goes the next couple of days. So, take it easy, everybody. See you soon.